Hey guys, welcome to my channel. In this video, we will try to design a hypothetical submarine and calculate the maximum depth that it can dive into the ocean without getting crushed. So we want to have some variables. We want to understand what is the thickness, what is the material of that submarine, and what is the maximum depth that it can dive into the ocean. So first, we need to have our specifications. We need to understand the material, we need to understand the dimension, and so on. First, we will assume that our hypothetical submarine has been made of cubic square structure and shape, and its structure is from oak wall. So let's assume hypothetically this is our submarine. The wall thickness will be 0.2 meter and the length will be 1.5 meter. The height will be 1 meter and the width will be 0.5 meter. Now we want to calculate the maximum depth that this submarine can achieve. So first we need to calculate the internal length, internal width, internal height, and ultimately internal volume. So now that we do have all calculations, we could easily multiply the length with width and height in order to calculate the volume, external, internal volume, and then extend it to the next level to determine the maximum depth this thick wall wooden submarine can achieve in the ocean without succumbing to water pressure. So what are the steps for the analysis? As I mentioned earlier, first we need to calculate the internal volume, which is equal to 0.066 cubic meter. Our material is oak wood, and the density of oak wood is approximately 700 kilogram per cubic meter. Now we want to calculate the mass of submarine walls. The volume will be total volume minus internal volume. The total volume of that submarine will be 0.75 cubic meter minus 0.066 cubic meter, and 0.684 cubic meter will be the volume of the walls. So what is the mass of volume? We will multiply the density of oak wood with the internal volume, and we will get the total mass of this submarine, which is equal 478.8 kilogram. So the next thing would be calculating the buoyancy factor. What is the buoyancy? Buoyancy is the resistance that the water shows and prevents the objects from easily getting submerged into the water. Let's assume that we do have object, and this object is our submarine. As we said, it's roughly equal 480 kilograms, and there will be a buoyancy force FB, which prevents it from getting drawn into the water. However, our object has mass itself, so in order to get dived into the water, our object's force should be more than the buoyancy factor. So weight of the submarine will be weight multiplied by gravity, which the force that our submarine applies to the water will be equal to 4,699.39 Newton. On the other hand, the buoyance force based on Archimedes factor will be then multiplying the density of water and multiplying by volume of submarine and gravity, which will be 7,539 Newton. So what is the next factor? We want to determine the water pressure in depth and see how depth we could achieve. So the water pressure will be achieved by multiplying the water density, gravity, and the distance we could travel. So in this equation, our unknown is the distance. So we need to have the water pressure and other variables. So the density of water is 1,2500 multiplied with 9.8, and we need to calculate the pressure. So the compressive strength of oak wood is approximately 50 megapascal. So we do have the pressure, and based on that we can calculate the maximum depth that we could achieve is 4,951 meters. So what are the conclusions and what we learned from this video? While the thick walls enhances the submarine's ability to withstand higher pressure, if we increase the thickness of wall, we will reduce the internal volume. And if we reduce the internal volume, it will affect the buoyancy calculation and could reduce the maximum depth that we could achieve. Theoretically, submarine can still reach depth around 4,951 meter, but it is in theory. There are so many unknown and variables in real life which we need to calculate, including the mass of passengers and other resistances that we have not took them into action.